Hey guys, Papaya here, and today I'm going to be teaching you how to use logical branches. So this includes like the logic behind like comparing things basically for Dolphin. Um, so basically we have two different sets of instructions. We have this stuff up here, which is how we change a specific register. Let's go to the register, CR. So this CR register, from what I've seen, this always stays at 88, but it could change, I don't know. But the first one or two will change based on how it compares them. So let's start with our first one. Our first one is CMPLWI. And what this will do is this will compare our first specified register with whatever number we say. I've got this one right here. So this is CMPLWI, register 8 and 20. So if we take a step, so this is gonna load, what was it? So it loads something into register 5, and then it loads something from the pointer we just put into register 5, and then it compares the variable we just got to register 20. This is the controls, that's what it is. So it's going to compare it to 20, and if we look at register 8 is 0, 0, which is not equal to the number 20. In hexadecimal assembly, or in hexadecimal, it would actually be 1, 4 to say, like to write 20. So it's going to compare it, and as you can see, this CR changed from 20 to 80. So 80 means that it is probably less than, I don't know how it works, honestly. And then we have this thing down here, and I'll be explaining that later. This basically just, actually I'll explain it now. So here we have all these things, BEQ, and this can be a minus or a plus sign. It doesn't matter, well, it sort of matters which, but you do have to include either a plus or minus sign after it. And then you want to, oh, I forgot about that, dang it, okay. So for this one, it's BEQ, branch if equal to plus. So that means if register 8 had been 20, then it would want to branch to this address right here, which just happens to be right here. And if it was so right now it's a minus sign, that might be hard to see, but it's a minus sign. If it was a plus sign, so since it's a minus sign, it expects it to not happen very often, or it's going to happen less often than not. It's just going to pass through. If it's a plus sign, then that means the opposite. It means that it thinks that it's going to happen a lot more. For instance, if you were checking if the player has died or not, if they lost all their HP, normally every time you are checking that, you're going to expect the player to not be dead. And so you're going to use a minus sign before you branch to where it does all of the logic with like game over screen and all that. We have another one here, branch if not equal to, branch if greater than or equal to, branch if less than or equal to, branch if greater than, or branch if less than. Down here we have a different type of thing. Oops, shouldn't have done that. So I have this part bolded just so that it's a little easier to tell what's going on. Basically, the non-bolded parts is the BLR. So like right there, BLR, if you saw my last video, which hopefully you at least watched part of it and saw this part, it basically says, hey, I want to go back to where I was before I was in this branch. And you can't just use it. You have to set a specific register. I think it's either CTR or I don't think it's LR. I think it's CTR. But I don't know how to do that, or it might be I don't know. I don't know. Anyways, I think it's CTR that lets you branch back to where you were. So if you are, the only reason that I can do that, let me go to where this starts. So this, if I follow this branch, then it takes us back to where we were. So this is my thing, and as you can see, right after it is a BLR. So I kind of did this the cheapo way, and instead of branching back to here and then having it execute BLR, I just had it do the BLR so that it goes back to where it was before. I don't know why I did that. So that's why I'm using BLR. If I wanted to, I could change all of these to be branch. I could change this one to be branch if not equal to, or BLR, BNE, and then LR. So you can do this with any of them, not just the LT. The LT means less than, just like in this one, how that means less than. But you can use greater than or equal to, whatever you want, as long as you want, as long as you know what you're doing, as long as you know what you want. So let's see, what else was I explaining? Oh yeah, so that is the that is how the game knows what you want to do. And I think there's a couple other ones now that I think about it. You might be able to do like BLEQ minus, and that would be like the BL, so like, oops, not there. Let's see if there's one that I can find really fast. Not okay. Basically, BL is the thing that says, hey, I want to branch. Okay, right here. So BL will take us to the beginning of this, and then it will MFLR. Yeah, sorry. And then at the end, it will do this BLR, and it will branch back to the one that I was just at. It'll go to right there. So you might be able to do that. I don't know for sure, so you should probably look that up before you use it, or just try it. In fact, I can just try it. BLT, nope, BLEQ minus. See if that works. Nope. It might be BEQL. BEQL minus. Nope. Okay, so you can't do that, or if you can, it's in a different way. So anyways, we have a couple other ways to change the compare register though. We have CMPW, which will compare two registers with each other, and it will compare this one to this one, I believe. And so if you wanted to test if register A was less than register B, because that does matter, then you would want to do register, well, you want to do whichever one is less than first if you're testing for, I'm struggling to find the right words. So like if you want to test if, I don't know, the RNG variable is less than the HP, which isn't going to happen very often most likely, then you would compare, but you want to know if the RNG is less than, then you would compare register A, the RNG variable, to register B, and then you would branch if it's less than, only if it's less than. If you did it the other way around, then it would only branch when the HP was less than the RNG variable, which would happen a lot more often, I would assume. So that's that. There's this one, which I don't understand, CROR 121 or something like that. It's either 121 or 212. I don't remember, but it's I don't understand it, but it changes it somehow. And then we have this monstrosity. Let me see if I can find that really fast. Yeah, so right here. It doesn't have the period, and the period is what is important. So there's a couple of instructions that can have this period. And the period just makes it so that it actually affects the compare register. It either does an or an and with it, and then compares it to, I don't remember. It's extremely complicated. This whole thing is just ridiculous. But yeah, so you can do that. You can do it. I think you can do it with ADD, not ADD, AND. I think you can do it with or. So yeah, you can do it with a couple, but basically that just makes it change it, and I don't understand how it changes it, so you'll have to do research on that. But yeah, so those are our ways to change it. Those are our ways to actually utilize it. Not that one though. That one doesn't work. And yeah, so let's go back here so that I can show you if we set the PC, and then if we go to registers and change this to the number 14, which is equal to 20, then it will, so this should change the CR to 2000, which it did. So now we are probably going to branch 2 right there. Let's see if we go here. Yep, we go right here. Yeah, so this is just testing for, well, yeah, it's testing for controls. So the reason that I'm making this video, and I actually didn't write down the person's name, so I'm sorry about that. I'll put their name in the description. I just checked. The person's name is Zedinek. But they are trying to do something with, what is it called? The animation for something. So, to explain what you're going to want to do, this is going to be really complicated, and this is the hard part. We're gonna go ahead and do that so that I can see. Oh, we're actually gonna get rid of that. Okay, so I found a better one, a better example than what I was rambling on about before. Basically, so right here I'm doing an AR code, but that's complicated and I don't remember what I was doing with it. But so here we have set up, but right here, so it sets register 4 to something, and then it loads something into register 0 from the pointer at register 4, and then it compares it to 0. So register 4 is actually pointing to the current item that it's trying to look at to see if it should say, hey, you have this item, or hey, you don't have this item. If it's 0, then I don't have the item, and if it's 1, then I do have an item. This type of variable is called a Boolean. It's either 0 or 1, and anything else just doesn't matter. So if it's 0, it's going to branch here. It's going to compare register 7 to the number 5. So it's going to see, hey, do I have 5 items loaded, because it can only load 5 at a time. And if it is, if it's greater than or equal to, then it's going to branch back, just like how we were talking about earlier. It's going to branch back to where we were before this, which is in one of these two things, but I'm not going to click on those. And then it's going to add 1 to register 6. And then this is kind of a complicated one. It basically branches back to somewhere unless it is greater than something. So it does a little bit of comparing. I don't think it affects the compare register. I think it just says, hey, if it's equal to, then continue doing this loop. So this is basically just a loop. It's a for loop for those of you. I think it's a for loop. Anyway, so it's basically just saying, hey, if register 6 is less than the number of items that we have, then we want to keep doing it. But if register 6 is equal to it, let's just say that number is 10, say there are only 10 items in the game, then it doesn't want to do it anymore, so it'll just go to the BLR. But so anyways, then it'll go back here. It will add, so register 5 has item 0, which doesn't actually exist, the pointer to that, and then register 6 is how many items we have checked. So when we get it to it the first time, when we check the first time, it's just going to be 0 because there's no item for it. But if it's the second one, then I might have that item. I don't remember what item that is. And so it's going to add 1 to it. They're all bits. They're not bytes. Sorry, they're bytes. They're not half words or words. And so it's going to compare. It's just going to keep doing this. If I wanted to say, hey, I don't actually want you to display this specific item, or I want you to display a different texture for this item, then I would want to have a branch function. I would want this to branch somewhere outside of memory. In fact, let's go to somewhere outside of memory. Let's just go to right here. So then I would want to, and I'm going to start writing my code. So I would want to CMPLWI, and actually let's set a breakpoint there so that it's easier to go back to it, and then we are back here. So we want to compare register 0, not register 0, register 6, because I want to know which item ID it is, to, let's just say that I wanted to do the 4th item. So we're going to do, oops, wrong thing, CMP LWI R6 and the number 4. And then I would want to be NE minus, and then I would want to branch back to where it was. And if you watched the last video, you will remember that we don't just input a target address. So like I can't just do 0x80191123 or 20 if that's where I want to branch back to. I have to actually do the math. I have to subtract 8176, like I have to subtract whatever this is from, or I have to subtract this from that, and then go, and then just enter that in. And yeah, so then I would want to do that. So if it's not equal to 4, then I don't care. If it is equal to 4, then I will continue going down here, and I will say, hey, let's just say we want to not display it. ADD, so then we would ADDI R6 1, and then branch, oops, and then branch back, and we would want to branch to the beginning of this. This is kind of a bad example too, but we would want to branch right there. So basically what I did is I just said, hey, we're just going to add register 6 together, register 6 and register 6 plus 1, and then we're going to go back to right here. So we would want to branch to right there. I'm not going to do the math for that on camera. But yeah, so that's basically what you would want to do. However, in your case, you would instead want to, so like I compared register 6, you would want to do something similar. You have to find the pointer to so like let me look at registers. So let's just say that this was your pointer. I can't make it super visible, but that right there, 801397F0. If that was the pointer that you wanted to, like of the animation, then you would want to compare register 4 to like the low word of register 4 what would you want to do? Oh, you know what? You would want to load the pointer that you want into register 4. So let's just say that it was, in fact, this 801397F0. Let's just say we're going to put that into register 17. And then you would want to do our wrong thing. You would want to do this one right here, CMPW, and then you would want to do register, in my case, register 4. Let me do that. So register 4 and register, let's just say 14. You would compare those two, and then if it's equal to, then you would branch to a different place, and then if it's not equal to, then you would just go back to the main loop, and if it is equal to, then you would want to run your code there, because you want to change the animation speed for a specific thing, so you want to make sure that that specific thing is there. So all you have to do is just figure out which pointer it is, or which register holds the pointer to the what is it called? To the animation variable, and you would want to just use your logic to only run it when it was that. And with that, I think that's all that I wanted to talk about. If you have any questions, I'll do my best to answer them, but as you can tell, I'm not great at explaining things. So yeah, thank you for watching, take care, and I will see you later.